Calculus! All right, AP Calculus AB, we're talking about self-check 3.3 solutions, so this is going to be the key. All right, so number one, we have the function given by this thing, and we're looking for increasing and decreasing. Definition of increasing is increasing.
When f prime is greater than 0?
Yep, decreasing, someone else?
Is less than 0.
There it is. Okay, so we're looking for f prime. All of these are dealing with f prime. So taking the derivative of this, f prime of x, that is going to be equal to 3x squared minus 12. And then from there, I need to find where the critical values are. So 0 is equal to 3x squared minus 12. So solving, I'm going to add the 12 to the other side. So I get 12 equals to 3x squared. Divide both sides by 3. 4 is equal to x squared. Therefore, x is equal to plus or minus 2. So from there, we go ahead and we should have made our x-axis at the very beginning. We have a negative 2 right here. We have a positive 2 right here. And then we need to do our test points. And I'm testing into f prime, not into f, so don't make that mistake. I'm going to test over here. I'm going to test 0, negative 3, and 3. When I test negative 3, plugging in for here, I'm going to get a positive number here, and that's going to overwrite this one. So I'm going to get a positive, which means we're increasing. Over here, we're going to get a negative, which means we're decreasing. And over here, we're going to get a positive, which means we are increasing. Now we're choosing the correct interval. So it says increasing for x is less than 2. That's true. Decreasing between the interval and increasing for x is greater than 2. Correct answer is A. Questions about number 1? All right, number 2. It already tells us the derivative. How nice. At how many points will the graph have a relative maximum? So there's a shortcut for number 2, and I'm going to show it to you right now. Actually, is there a shortcut? Oh, okay, so there's a shortcut for relative extrema, not for relative maximum. For each of these, you have to find the 0. So this one is going to be what critical value will I get for this? X equals 0. Next one is going to be x equals 2, and there it is. So graph them all in the number line. The shortcut is going to be coming up probably somewhere else. I have negative 3, 0, 2. My test points are going to be 1, negative 4, and 3. So when I plug in negative 4, this thing, by the way, is always going to be positive. Don't even worry about him. Only worry about these two. When I plug in a negative 4, this is going to be a negative. This is going to be a negative. Negative times a negative is a positive. Therefore, this one is increasing. When I plug in a negative 1, this one's going to be negative. This one's going to be positive now. Negative times a positive is a negative, so that's going to be decreasing.
Wait, if you plug in negative 4 into x with minus 2, that would be negative.
Yep. So, and this one is also negative. Double negative. Yep. Good catch. When I plug in 1, this is going to be a negative. This is going to be a positive, so we still have decreasing. And when I plug in 3, I'm going to get positive and positive, so this is increasing. What's the definition of relative maximum?
When the f prime sign changes
From
positive to negative.
Positive to a negative. All right, so these are f primes. I guess I should have wrote a positive here, a negative here, a negative here, and a positive here. So we're looking for a positive to a negative. That goes from a negative to a positive. This is the only one that goes from a positive to a negative, so the answer is just 1. Preguntas? All right, going on to number 3. So we have this graph, and we're looking for concave down. Definition of concave down is?
When f double prime is less than 0?
Very good, yep, f double prime. And we're only, this is kind of like f of x, as I kind of told Rochelle while she was working on this. So we need to take the derivative and the derivative again. So f prime of x, if this is assumed to be f of x, I guess I could have just wrote y prime, is equal to, I bring down the 4, it's going to be 12x cubed minus, is that going to be 48x squared plus 48x. And I don't care about that one. I care about f double prime of x. I should have color-coded this, but I'm going too fast. So 3 times 12 is, I don't know what I'm writing there, 36x squared minus 96x plus 48. That's one we care about. We need to figure out where this thing is negative. So to figure out where this thing is negative, I'm going to look for possible inflection points. And then I'm going to find those intervals. So possible inflection points, I plug in 0. And I'm going to have to factor this thing on the right. It looks like every single thing over here is a multiple of 12. Yeah, so I'm going to factor out 12 times 3x squared minus 8x plus 4. And then I have to do advanced ninja star for this one. Maybe I should make this smaller and over here.
Yeah, this one took like 5 minutes alone.
Yeah, it was hard. So again, advanced ninja star, I do 3 times 4 and I get 12 over here. I do -8 in the bottom. So what adds to -8 multiplies to 12, and I'm going to be left with 3. Oh, I remember now talking to Rochelle. She does it a different way. If you do it your cool box way, that's also a way to do it. So then what multiplies to 12 adds to 8? You guys got, or adds to -8? Uh-oh. Do we?
It's -6 and -2.
There it is. And then you have to go ahead and simplify these fractions. This fraction right here, is already simplified, so it's 3x minus 2. This fraction reduces to x over -2, or 1x divided by -2. So that's just going to be x minus 2, which means that is the factored form of this. Don't forget your 12. I'm going to stick it off here to the right-hand side. That's equal to 0. Divide both sides by 12. Bloop, it's gone. And I get my x coordinates, so this is going to give me a positive 2/3. That's going to give me a positive 2. There's my number line. There's 2/3. There's 2. I'm going to pause here so we can digest what's going on because I've gone really fast for now. Yeah, doing that advanced ninja star, that was from last year. I know
Why
that.
is it called an advanced ninja star?
That's what I call it. I don't know. You can call it whatever you want. You can call it cool asterisk thing. You can call it factoring method.
The problem was the advanced.
Oh
I
yeah.
was wondering if it was different from normal.
The non-advanced ninja star just looks like this.
Oh.
The advanced goes like that.
Whole number bit.
Technically, everything is an advanced ninja star. I always start out by teaching the normal ninja star, and I call it a ninja star because of what the elementary school teachers call it. They call it a ninja star, so I am just following with the tradition.
Okay.
Gotta go back for clarification.
Fine, we'll do it that way, Mr. Sindel. Okay. All right, we're good up to this point. All right, so now we have to do test points. So I'm going to test between 2/3 and 2. There's a good number 1, 0, and 3 over here on the right. So I'm going to plug into, it would be nice to plug into the factored form actually. So the factored form has that 12. I'm going to plug into this thing right here. It's the easiest thing to plug into. And that's just kind of a method from here on out, especially on the AP test. Plug into the factored form of f double prime. It just goes faster because this is the thing that will cause a critical value. This is the thing that will cause a critical value. Those are the only two things that will switch signs. They're easier to see that way. When I plug in 0, I'm going to get a negative and a negative. Negative times a negative is a positive. So this is a positive, therefore this is increasing. When I plug in a 1, this thing is going to be a positive because it's 3 minus 2. This thing is going to be a negative. Positive times a negative is a negative. Therefore this is, teacher error. Who wants to catch it? I caught it already. Hint, we're talking about f double prime.
Oh, you're not plugging into that. You're plugging into the.
Not quite. See if you can find the error. It's up there.
Increasing and it's not increasing and it's not.
Yeah. So what should I have written?
Concave up.
Yep. I should have written concave up here. And this one is negative, so this one is, log it in your extra credit tracker arrow. This one is concave down. And this one is going to be, when I plug in a 3, it's going to be positive and positive. So that's going to be positive times positive is positive. Therefore, it's going to be concave up. I don't know why I did concave with C's over there. I usually just write con. It's the con, man. Okay, so we're asking where is it concave down? It's obviously concave down between 2/3 and 2. Which one of these say it's between 2/3 and 2? It needs to be greater than 2/3. Greater than 2/3 and less than 2. There it is. It's E.
It's so weird because this is the only one that I guessed on. I thought I understood all the other ones, and this is the only one that I guessed on that. I got it right.
I hate it when that happens. It makes you feel like you don't know as much as you do.
I'm like, yeah, I can so confidently get the completely wrong answer now. But anyway, that's what we're doing this for.
All right, questions on 3. No questions. We're going to 4. On the back. Okay, so we have this function, and we're looking for all the points of inflection. Definition of points of inflection.
F double prime sign change.
F double prime sign change. We don't have F double prime. Let's get it. Here's F prime. F prime of x. I bring down the 7, and I just get 5x to the 6 plus 24x to the 5th plus 30x to the 4th plus 1.
Okay, so why 5 plug it at 0
Good.
times exercise?
Good question. I was hoping you'd ask that. So 7 is brought down here, and then the 7s cancel each other out, and you're just left with the 5. Yeah, it's a skipping step. Oh, what just happened?
Oh,
Command Z just ruins everything.
What another easier way would be thinking is if we do times 5 times 7 equals 35.
And then divide by 7.
Simplify it, it's just 5x.
Perfect. Yep, that works. All right, so far so good on F prime. Here's F double prime. F double prime of x. When I do F double prime, 6 times 5 is 30. Minus 1 is going to be 5. 24 times 5 is going to be 120. So plus 120 x to the power of 4. I did 5 times 20 and 5 times 4 and then added the results. Plus 30 times 4 is 120. Again, x to the power of 3. Looks like everything here is divisible by 3x to the cubed. 3x to the power of 3. 30, sorry, yeah. So that means F double prime, my cool factored form is 30x to the power of 3. All of that, x squared plus 4x plus 4.
Yeah.
From here, we need to figure out where those inflection points are. We can find possible inflection points by plugging in 0. Oh, by the way, this is not the most factored form, so I'm going to do that right here. But I'm going to plug in 0 after this, so I'm going to get 0 equals to the factored form. Let's factor this even more, because this thing right here can be factored. So I'm going to leave that 30x to the power of 3 over here. This is going to turn into something times something else. What does this factor as? Actually, it can be factored like this. Something squared.
Oh, would it be x plus 1?
Then x plus 4. Wait, why
No,
is something
no, no,
squared?
no, 2.
There it
It's
is.
gotta be 2.
X plus 2 squared.
Why
There it
it
is.
X plus 1 and x. No, it would be 5. Okay.
All right, so this, when I plug in 0, that means that 30x cubed is equal to 0, and that x plus 2 quantity squared is equal to 0. From that, I get x is equal to 0, and negative 2. Wait, is that right? Yeah, negative 2 is equal to 0. What am I doing? Negative 2 equals 0. Negative 2 is the x that I'm looking for. This is what happens when you're sick. Still blaming the sickness.
Well, yeah, never mind. Okay.
All right. So far, so good. Let's go ahead and make our x coordinate, or x axis, I should say. That's our x. Boonk. Boonk. There is our negative 2. There is our 0. We have to check if these are actually inflection points. Those are only possible inflection points. In order to be an inflection point, someone aside from Ben, what's the definition of inflection points again?
Would it have double prime sign changes?
Yeah, sign changes. So we're looking for the sign change. When I plug in my my points, I'm going to check negative 3, I'm going to check negative 1, and I'm going to check 1. When I check negative 3, I'm plugging into this factored form right here as much as possible. So something cubed will always take the sign of whatever you have. And this thing right here will always be positive because it's always squared. So don't worry about this x plus 2. You're only looking at this x cubed. So when I plug in a negative 3, it's going to take the sign of the negative. So this is going to be a negative. When I look at negative 1, it's going to take the sign of the negative. And when I take the sign of 1, that's going to be positive. So there's only one inflection point. It's at 0. It's B. Ooh. Questions? All right. I should be wearing my hat now. I don't know why I'm not. I'm going to wear it for number 5. All right. We have this fun function, and we're looking for which of the following is true. It's asking about increasing and decreasing. So are we talking about f, f prime, or f double prime?
F prime.
Yep, f prime. So, and we don't have f prime, so we need to find it. So, f prime of x. Uh-oh. We have a fraction. We hate fractions. What are we going to be doing?
Quotient.
Yes.
Quotient rule. Quotient rule is what? Oh, yep. You said right. High, D, low, all over low, low. All right. So low is x. D high is 1 over x. Minus high is natural log of x. Bless you. Low is times x. All of that is going to be divided by low, low, x squared. Simplify. These x's cancel each other out, and you're just left with 1. So that means that my f prime of x, slightly more simplified, is going to be equal to negative x natural log of x, all divided by x squared. Simplify that even more. Oh, whoops. There's a teacher error. Catch it. Yep. There should be one there. Again, log it in your extra credit tracker.
So log in the extra credit tracker, you just write the date?
Just write the date. Yep. The date that you caught Mr. Sandell's error. I'm getting smarter every time I make an error. All right. So now we have to find all of the f prime equals 0 or where f prime does not exist. How do I get all of the f prime does not exist?
So eventually the ln is going to fade out and then this one goes
Yep.
up.
Denominator what?
That's what it equals.
Yeah. So f prime does not exist for the following values where x squared, the denominator, is equal to 0, and f prime equals 0. You just set the numerator equals 0. So 1 minus natural log of x. Sorry, x natural log of x. Let me go back here. 1 minus x natural log of x. That needs to be set equal to 0. So from there, that means x equals 0 is going to be the critical value, and that x natural log of x is equal to 1. So I need to solve for this one. So I need to,
Would you multiply it to e to natural e or something?
yes, I think you do need to, what is that term called? Exponentiate each side. Is that the right way of doing this? I feel like we've made a mistake somewhere. Have we not made a mistake? This was high D. Oh, yeah, we did make a mistake right there.
Should just be 1.
Should just be 1, yeah. I was like, we are doing hard math. We shouldn't be doing that hard math. So that should be 1, which cancels each other out. So just get rid of it, get rid of it, get rid of it. And where is natural log of x equal to 1? It's just a property you have to know about natural
It's like a
logarithms.
decimal. Point something. Shouldn't it be like 0.5 or something?
Nope. It is a decimal, but it's a number that you know. It is e. Natural log of e is equal to 1.
Oh, right.
Yeah, because it's just a property you need to have memorized. Natural log of e is equal to 1. Just like log of 10 is equal to 1. Because that's log base 10. Because natural log is really log base e. Because log base e of e equals 1. E to the power of e. Yeah. Anyway, so x is equal to e. We have that. And then we need to know if it's increasing or decreasing, so we need our x-axis.
Isn't it? Oh wait.
We good? All right, so there's 1, there's e. E is about 2 point, oh gosh, I'm 2.7 something, I think, maybe. So let's plug in some values. This is going to be 2, this is going to be 3, this is going to be 0. When I plug in 0, then I'm going to get on the top a natural log of 0. You can't actually do natural log of 0. That's outside of the domain. It has to be slightly greater than 0 because that would be negative infinity, which is non-exist.
Wait,
So
why is the 1, should the 1 be 0 on the number line?
Ah, man, yeah. That's the reason. Yeah. Making so many errors today. You guys love it when Mr. Sandell's sick because you get all the extra credit. 0 and E.
Well, that's almost so we can be able to catch it.
Well, yeah, you're kind of usually let us catch it. Anyway, so
Yeah, so there's 0. We can't plug in anything over here. It's not in the domain. Do we realize what, or do we remember is the correct word? What natural log looks like on a graph? It goes,
Like something like this, like an L, basically. Or,
yeah, so you guys, I think, are getting it.
it's like,
So
like this.
yeah.
goes
Okay, we've agreed.
like that.
Okay.
But there's nothing over here in the negative. It's not in the domain. You're not allowed to plug in negative numbers.
Unity x can never be negative.
It's just like e to the x can never be negative. It's kind of like the inverse function of this. This is natural log of x. E to x looks like this. It's flipped over that line y equals x. It's the inverse. We're talking about that in algebra 2 right now. Anyway, you can't have anything negative, so don't worry about anything over there. There's no suspect point. Or there's no point to try. So we can try 1 and we can try 3, though. When I try 1, I'm going to get natural log of 1. Natural log of 1 is a negative number. So it's going to be 1 minus a negative, which is a positive. It's going to be a positive over a positive, which is a positive. Therefore, this is increasing. When I plug in a number that's bigger than e, remember, natural log of e was 1. Natural log of a number bigger than e should be bigger than 1.
What's the approximation of e?
2.718. Let me just... Euler's number. 2.718281828. Yeah, so 2.7 is a good approximation for us in calculus.
2.72.
2.72, sure. You can round it 2 decimal places. Anyway, so this was about 2.7. So we plug in a number bigger than 2.7. That means this thing right here is bigger than 1 because natural log of e was 1, but natural log of something bigger than e is slightly bigger than 1. So 1 minus something slightly bigger than 1 is going to be a negative. So this whole top is a negative, bottom is always positive. So this is now going to be a negative, which means it's decreasing here. All right, so A says f is increasing for everything greater than 0. It's not only up until e. F is increasing for all x greater than 1. That's not true because it's all x between 0 and e for increasing. Decreasing. Decreasing is bigger than e. So it's between those, nope. Between those, nope. It's bigger or greater than e. There we go, e. E for e. All right, questions on number 5? No questions? All right, let's go on to the next self-check.